Internet, in which we have the network fundamentals, the Internet, the World Wide Web, the Internet protocols, and the security. In the network fundamentals, we have the scope, the ownership, and the topology or configuration. Under the scope, we have the LAN or the local area network, the MAN, whereby it's a metropolitan area network, and the WN or WAN, which is wide area networking. You may think of WLAN, which is a wide local area networking too. So let's talk about, let's write those down actually. After the scope, we have ownership, whereby there's closed ownership, and then there's also open ownership. Closed ownership is owned by large companies. I would say, maybe, let me do example with applications. Microsoft is a closed ownership company. And on open source, we have, let's say, something like VS Codium, where everyone is willing to help each other build the system or so. Then after the ownership, we have the configurations, whereby we have buses or bus and ring, which are Ethernet. Then we have stars, which are wireless network in central access points. And then again, we have the irregular ones. Now, in configurations, whereby there's a bus and a ring. A, which is bus. We have a computer right here, which is connected to other computers via the Ethernet. Each computer communicates with another computer via one network. There won't be any information that's going from this computer and to an external computer, maybe my PC, if it's not connected to the same Ethernet as the other ones. Then the second one is rings, or a ring. It works the same way as the Ethernet, just that all the computers are in an enclosed circle, whereby we have a computer in each point or most of the points, and they communicate with each other as the same as the Ethernet. The only key difference is that here the messages from this computer don't go there, then go there again. They only move in one direction. So if, let's say, it's those one-way roads in highways sometimes, or freeways, you only go this way. Whereas in buses, this computer right here can communicate with this computer right here without any problem at all, without actually communicating or sending a message through other computers like this one or this other one. The message goes straight to that other computer. Now, number 3, we have the star. Still in configurations, whereby we have a central computer which communicates with all the other computers that are outside of it, or that are connected to it. So this computer right here receives a message from this one, and then it takes the message to whichsoever computer that this one is sending the message to. Then we have the irregular D, which is irregular, whereby computers just communicate with each other howsoever they want to. Say, for example, we have this computer right here, this one, this other one, and then one last computer. This computer is going to communicate with this one. It can also communicate with this one. This one, again, can communicate with this. And then, it's just a mess. There's no proper communication or there's nothing proper that happens with the irregular things or computers. Then again, I think we spoke about all of them: bus, ring, star, and irregular. All right. Now let's move to protocols. Where a protocol is rules by which an activity is conducted. Now the protocols have carrier senses with multiple accesses in collision detection or detectors. Usually they are referred to as CSMA or with collision detection. The CSMA just stands for carrier sense with multiple access. Now the CD stands for collision detection. Now these CSMAs have what we call the nodes, in which the nodes contend for the right to send a message. And they are usually used in Ethernet or bus network. And the silent bus from the Ethernet just provides the right to introduce a new message. Now, in the carrier sense multiple collision, let me change colors. Collision avoidance. These ones are for collision detection. Now we have collision avoidance, which is going to be CSMA /CA, in which CA stands for collision avoidance. Whereby they are used in Wi-Fi's and hidden terminal problems. Let me name those. And hidden terminal problem. Now, the hidden terminal problem, with an aid of a diagram. Let's say here we have the range of A. Here we have the range of C. Then this is the range of B. B, A, C. In these ranges, there are going to be access points or an access point which can be found anywhere. Or maybe let me put it in the middle of all these things. The access point can be found in the middle of all the ranges. That's the access point. then we have a system in each and every range whereby none of the systems can hear each other, although each can communicate with the access point. This machine right here communicates with this one, but it can't communicate directly with this one or communicate directly with that one. That's just Wi-Fi. That's how Wi-Fi works. So each device just communicates with the access point and never with each other. Now, when you're connecting networks, you can use repeaters, bridges, switches, routers, or anything that you can think of. So the repeaters are those routers that you see in each and every lecture hall. I think they're enclosed in some big black box with a glass to show the internal parts. Right, those are repeaters. They just extend the network. Then number 2, we have a bridge which connects to compatible networks. I'd say Bluetooth in this one. I don't have a better example. A bridge just connects to compatible networks. Then the third one is a switch which connects several compatible networks. A Bluetooth repeater. There are Bluetooth repeaters whereby you connect a lot of devices to one device. I don't know how they work, but I've heard of them. Switch. And then the last one is a router which connects two incompatible networks, resulting in a network of networks, in which it's called the internet. Let's see, connecting networks. After connecting networks, we go to the IPC, or the inter-process communications, whereby we have the client server and the peer-to-peer servers. We have the client server, whereby one server has many clients. The server must execute continuously without stopping, and the client initiates communication. For example, client server. For example, if you create a server of your own, let's say this is your home server, you can allow each and every device in your family or household to use the server, right? This server must run continuously because all the devices in your household are depending on it. If it crashes, then no one is going to communicate with each other or so. And the server itself initiates, the client initiates communication, whereby if I'm requesting for movies from this phone, it's going to communicate with the server, then the server is just going to give that particular phone or the client with the movie that it just requested. So the client server is one server with many clients. It has to run continuously, and the clients are the ones who initiate the communication. The second IPC is, we have client and then we have P2P. The peer-to-peer or P2P. The peer-to-peer is just two processes communicating as equals, and the peer processes can be short-lived. When these things communicate with each other, let's take you and your friend, for example. You communicate with each other as equals. No one can be above the other one. Or well, they can, but for the most part, you talk as equals, right? So the peer-to-peer is just two processes communicating as equals. And the second one is that it can be short-lived. You and your friend, you can just run out of a conversation or things to say when you're with each other. So that's short-living. Okay, now the other part is the ISLs, or the Internet Software Layers, whereby it is applications, transport, networks, and links. Now, the applications just construct a message with the address. Gmail, for example, it just you put in the address and then it's going to take the message to wheresoever you are sending it. Right. Then again, in Gmail, there's a transport. Whereby it just chops the messages into packets. The message is not sent as a whole. It's sent as chunks. You'd find that if someone is peeping through whatsoever that you're sending through a network, they'll see another chunk, not the whole bulk of the message, just a part of it. Then we have the network, whereby it handles the routing through the internet. You can send a message to Jimmy and then it goes to maybe Alicia. So that's how networks work. And then we have links, which are the last part, whereby they just handle the actual transmission of packets. When the message reaches me, if you send a message to me, it's just going to be as a bulk. All right. Now, these layers, let me just put them in visuals, whereby we have the application, transport, then we have the network, and lastly, we have the link. What was I doing? All right. After this, we have data communication channels. In these channels, or the communication channels, they just pass digital information from one location to another, either with a physical transmission medium or a wireless transmission medium. Physical transmission or a wireless transmission medium. The physical part, the physical transmission medium, we have those cables or the twisted wires, which have two insulated copper wires twisting around each other, maybe yellow and white, red and white, blue and white, those ones. We have the what else do we have? The coaxial table or cable, spelled as coaxial cable. These are for physical. Oh, what did I first say? The twisted pair wires. Then we have the coaxial cable, and then we have those fiber optic cables, which work in a form of lasers. The information that they are carrying is distributed by lasers. Fiber optic cables. Now, with wireless transmission, we have those microwave signals or radio signals. Those towers, I can just say towers. They are called radio or microwave signals, which just travel in a straight line. If a call is coming on your phone, it comes to you, directly to you, because the repeating station or the radio signal is pointing at your device and whatsoever not. The second one, we have the satellite, which just eliminates the line of sight limitation. Whatsoever that's going on around the world, you can also see it, but with some delays, as it's a satellite. Now let's move into security. In the first part of the second chapter, it was attacks from outside, as you would have insecure or frequently reused passwords, and the sniffing softwares that may get installed when you are visiting websites or unauthorized websites, and so on. But here we have attacks that are from malware or viruses, the DOS or the DDoS, which is direct denial of service, or the DOS itself, which is a denial of service. Security again, whereby there are attacks as usual, and these attacks are caused by malware, as we are talking about the internet. Spyware, phishing software, Trojan horses, those things, they are caused again by the DOS, which is the denial of service. I did mention a DDoS. How DDoS's work is far more complicated, but it's easy to do those. You just send unauthorized networks or a huge workload of information to one server, and then that server is going to crash. It's not going to do anything proper at all, so it's going to crash. Then they can just get into your phone and take whatsoever you are having. If I am not wrong, that's how it works. Then the last one, we have the spam, which is just malicious links that come with messages. It's the same as malware, but with extra steps. Now, to protect yourself from these attacks, you need to have your firewall or firewalls up. If you do make a mistake of dropping your firewall, you're just risking yourself some things. Protection. You just close your firewall. I can get in and do whatsoever that I want to do with your PC without your authorization or without that window prompt telling you that someone wants administration access to your PC. Alright, so it's best to keep your full firewall apps. Then number 2, we have spam filters. I don't know how these ones work, but they do work for the most part. And the last one, we have antivirus software. Not just any antivirus software. If you do see a free antivirus software, just know that it's not actually going to protect you. Something that's free has a cost, and that cost may be you as a user. You are the payment to that software. So just go to the paid versions of antiviruses. I'd actually recommend Kaspersky. I used it and it was great. They protect your PC and your phone at the same time without compromisations of anything that you have that's important. Now, after security, all right, there's encryption. You know what encryption is. If you don't know, I also don't know, but it's very important. We have the FTPS, the File Transmission Protocol Service. Then we have the HTTPS, which is a routing link. And then we have SSLs, in which most of the time they are found in hosting services. And every website that is an HTTPS has an SSL certificate, right? Okay, now we have a public key encryption, which is used to encrypt messages and also to decrypt messages. I actually show you an example of that in action, but I lost access to that particular app, whereby you send a message, someone sends me a message, then they give me a code. Then when I receive the message, I'm going to input this code so that I can read whatsoever they sent, right? When they send maybe a hello, it's going to be in a form of 0 ones, maybe. No one can read these things, especially when it's like a million digits and blah 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 blah. You can't read those things, right? So it's best to have encryptions and decryption keys. Public key encryption. Which is used to encrypt and decrypt messages. And the certificates, they have certificates and digital signatures. Oh, I'm referring to the encryption. Encryptions have certificates and digital signatures. This will mark the end of this lesson.